How remote-controlled airplanes work. Remote-controlled airplanes, RC, are unmanned aerial vehicles, UAVs, controlled by radio signals from a handheld transmitter. These airplanes are a sophisticated combination of precision mechanics, electronics, aerodynamics, and wireless communication technology. RC airplanes come in various forms, including fixed-wing planes, helicopters, multi-rotor drones, or even model jets powered by jet engines. To understand how they work, we need to examine their structure, operating principles, signal transmission systems, and supporting technologies. 1. Basic structure of an RC airplane. A typical RC airplane consists of the following components. Airframe. This is the structural body of the airplane designed to withstand aerodynamic forces and serve as the mounting point for all components. For fixed-wing airplanes, it includes the fuselage, wings, tail section, and landing gear. For drones, the frame is usually a symmetrical structure with extended arms to hold the motors. Motor provides thrust for movement. There are two main types: electric motors, brushed or brushless; internal combustion engines, used for larger models. Electronic speed controller, ESC, adjusts the motor speed based on signals from the flight controller or receiver. Propeller converts the rotational energy from the motor into thrust or lift, depending on the direction and aerodynamic design. Flight controller, FC, acts as the brain of the airplane. It collects data from onboard sensors, gyroscope, accelerometer, GPS, etc., and processes signals from the transmitter to stabilize and control the airplane. Power source, usually a lithium polymer or LiPo battery, providing high current to the motor and electronics. Receiver receives signals from the transmitter and sends them to the flight controller or ESC. FPV, first-person view system, optional, includes a camera and video transmitter to send live images back to the pilot. 2. How it works. The remote-controlled aircraft operates through a feedback loop between the pilot and the vehicle. Transmitter sends control signals. The pilot uses a handheld radio transmitter equipped with control sticks, switches, and a screen. It sends radio signals, usually at frequencies of 2.4 GHz or 5.8 GHz, to the aircraft. Receiver decodes signals on the aircraft. The receiver on the aircraft decodes the radio commands and sends them to the flight controller or ESC. Flight controller processes signals and maintains stability. Based on sensor data, the flight controller adjusts motor speeds to maintain balance and execute commands from the pilot. Motors spin, generating thrust. The ESC adjusts motor speeds, allowing the aircraft to move, turn, ascend, or descend. 3. Radio signal transmission system. A reliable signal transmission system is crucial for operating remote-controlled aircraft safely and effectively. Frequency band 2.4 GHz is the most common due to less interference, long range, and support for FHSS, frequency hopping spread spectrum technology, to resist interference. Number of channels. Each channel controls a specific function such as throttle, roll, pitch, or yaw. Basic models may use 3 channels. Advanced systems can use up to 16 channels. Latency. The delay time between sending the signal and receiving feedback. High-end systems minimize latency for more precise control. 4. Sensors on aircraft. Modern remote-controlled aircraft, especially drones, include various types of sensors to support stability and automation. Gyroscope measures rotational speed to help maintain balance. Accelerometer measures linear acceleration and works with the gyroscope to track movement and orientation. Magnetometer, a digital compass that helps determine direction. Altimeter, barometer, or LiDAR, helps maintain stable altitude throughout the flight. GPS allows tracking of position, navigation to destinations, and automatic return-to-home functions. 5. How an airplane changes direction. A remote-controlled airplane changes direction by adjusting the thrust between engines or using aerodynamic control surfaces. Roll, tilting side to side. Increase thrust on one side and decrease on the other in drones, or use ailerons in fixed-wing aircraft. Pitch, tilting forward backward. Change the speed of the front and rear engines, or use the elevator. Yaw, turning left, right. Change the torque between clockwise and counterclockwise rotating engines. Throttle, increase or decrease overall engine power to climb or descend. 6. Software and configuration. Software plays an essential role in flight behavior and control. Firmware, e.g., Betaflight, ArduPilot PX4, allows customization of flight parameters, sensor calibration, and automation logic. Applications on PC or smartphone, used to configure the aircraft, monitor flight data, remotely control the aircraft, or program automated missions. 7. Flight modes. Most remote-controlled aircraft support multiple flight modes with varying levels of automation. Manual mode, the pilot has full control without stabilization assistance. Stabilize mode automatically balances the aircraft, making it easier for beginners. Altitude hold automatically maintains a stable altitude. GPS position hold, circle flight, maintains position based on GPS coordinates. Return to home, RTH, automatically flies back to the takeoff point when signal is lost or by user command. 8. Practical applications. Remote-controlled aircraft are used in many fields beyond recreational flying, aerial photography and videography, surveillance and search and rescue, precision, agriculture, geological surveying, flight, training and simulation, drone racing and light shows. 9. Safety and legal compliance. Remote aircraft operators must comply with safety instructions and regulations, avoid flying near airports, military bases, and restricted areas, maintain direct visual line of sight, VLOS, with the aircraft, register drones above a certain weight, depending on the country, use valid radio frequencies, and avoid causing signal interference. Conclusion: remote-controlled aircraft are an impressive combination of wireless communication, mechanical engineering, and intelligent control systems. Successful operation requires a solid understanding of flight mechanics, electronics, and safety principles. As technology continues to advance, remote-controlled aircraft are opening up new opportunities in research, industry, and modern entertainment.